Start recording. Okay, so let's do this. Double check. Okay, so perfect. Okay, yeah, so welcome to I actually have lost count which tutorial number this is, but because we're a bit behind in terms of lectures, we'll just continue with the theory and then we'll do code examples during revision. So we'll have like many revision lectures before your exam and before your semester test 3. So you should have plenty of revision before you have to write those tests. And so to those who wrote the SSA, your papers are still with the moderator, but they promised me that they would give them to me today. So by tomorrow, your marks should be up on eve. And then in terms of the practical test, there's another session on Saturday. So if you're writing on Saturday, just remember the session starts at 10. And it will be 2.5 hours. And then, yeah, so obviously the difficulty will be exactly the same as the practical test from yesterday. So, yeah, so please prepare accordingly. And then, yeah, so just also to remind you guys, the visited design pattern will not be in the test, right? So the GUI section will basically be all the GUI that you did up until we finished with the GUI. So there's no visited design pattern. So yeah, okay. Okay, so we looked at the observer design pattern, and then we basically did start having a look at it. And then we did say that it's the publish subscribe design pattern, which means that you have a group of objects that basically observe a subject, which in this case is also an object. But the whole point is that the subject will have a state that the observers are interested in, and the observers will then try to keep up or update themselves according to the state of the subject, right? So for example, let's actually look at an example here. So if we look at the observer structure, so we have basically an interface for the subject, and then we have an interface for an observer, right? So all observer classes, no matter how many they are, will always implement the abstract observer interface, right? So there's only one abstract observer interface, and there can be many different kinds of concrete observers. So what this means is that every observer will have the update method, right? So in terms of the observer state, that will differ, you know, like based on each observer, how they want to represent the state internally, but they will always have to implement the update abstract method to update their state, right? So that's the most important thing. And then the concrete observer observes a concrete subject, right? So this is the state that we're interested in, right? So the concrete subject will have a state, and whenever that state changes, they need to be able to notify all the observers, right? So as you can see, the subject overrides all the abstract methods from the abstract subject, right? And one of them is the notify observer method, right? So using this method, the concrete subject will then be able to notify the observers that its state has changed, and the observers will update themselves based on the new state, right? So that's the whole idea behind the observer design pattern, right? So you have observer objects that are observing a subject, and when the subject changes, the subject notifies the observers, and the observers will update themselves, right? Does that make sense? Okay. So let's continue looking at the observer participants. So the abstract subject knows about abstract observers, right? So in this case, for example, it will know about an abstract observer, and it will be able to attach observers onto itself. That just means adding to the list of observers, and it will be able to detach observers, right? That just means removing observers from the list of observers. And it provides an interface for attaching and detaching abstract observer objects. And the concrete subject, it stores the states of interest to the concrete observer object, right? So this is the concrete subject. So it stores the state of interest, right? This is the state of interest to the concrete observers. And it sends a notification to its abstract observers when its state changes, right? So whenever its state changes, it will call this function to notify its observers. Okay, and then let's look at the observer part of the design pattern. So the observers define an update interface for objects that should be notified of changes in an abstract subject state, right? So this is the function, or rather the member function that the design pattern is referring to, the update member function, right? So the abstract observer must have that, and every concrete observer must then update themselves according to, like their own unique implementation. Okay, so the concrete observer maintains a reference to a concrete subject, or rather to all its concrete subject, and then it stores the state that must be consistent with the concrete subject. So for example, an observer will have its own state that will in some manner represent the state that is stored in the concrete subjects, right? Doesn't have to be exactly the same format, it can be different formats, but the whole idea is that every concrete observer will have a state that is consistent with the state of the concrete subject. Okay, and then the concrete observer implements the update method to keep its state consistent with the subject. So here's an example. So let's say we have a messaging application where nothing happens until a new message is published, right? So, and all subscribed components need to be notified of the message, right? So an example of this is like, I think we mentioned the previous lecture, like let's say a blog where there's only one writer in the blog, and that is the subject, and then all the observers are subscribers, right? And whenever the subject publishes a message on the blog, all the subscribers get notified, right? Another example that's probably closer to home is WhatsApp, right? So if you have a group chat on WhatsApp, you can think of all the participants in the group chat as observers and also as subjects, right? So both of them are observers and subjects. And whenever someone posts a message on the group, all the observers get notified, right? Or you could think of the WhatsApp group itself as the subject and all the people in the group as observers, right? But in that case, the observers basically can change the states of the subject, which kind of drifts away from the design pattern, right? But there are many examples of this, but in this case, we are considering a very simple example, right? So the observer then will allow us to specify which components must subscribe, right, to the subject. So remember, this is where we use the attach and detach method of the subject, right? And they will always get notified when a new message comes in. And the observer then observes the subject for any changes and notifies components when a new message is published, right? So that is why it's also called the publish, subscribe, design pattern. So let's look at the code. So we have the abstract subject class, and so in this case, it's an interface. So you can make it an abstract class, but it's probably better design decision to make it an interface. And then you can attach an observer, you can detach an observer, and you can notify observers, right? And then, so this is just another extra function that will allow our observers to get the state of the subject, right? So obviously, you don't only have to have these methods in your class, you can add other methods if they will aid how your class functions. So let's look at the concrete subject class. So the concrete subject will obviously have a list of observers, right? Because that is how it's going to keep track of the observers. And this is just a flag to indicate if its state has changed. And this is the actual state, right? And then, so we can attach an observer. So this is just adding an element onto a list, right? So if the list is not null and the list does not contain the object, we add the object. And detaching is just removing an element from the list. And in order to remove something from an array list, we simply call the remove function. And then notifying the observers. So in this case, so we check if the state has changed. If it has not changed, then we don't do anything, right? So we just return from the method. But if the state has changed, then we basically reset it so that it goes back to unchanged, and then we iterate through the list of observers and we update the observers, right? So as you can see here, in this particular implementation, there's a local list that is created, and that list is basically the one that is iterated through and modified. But this is not the only way you could do it, right? You could also use this list that is here, right? The list that you created there. Okay, so, and then, so the get update method just returns the state as it is. Changing the state just means, so in this case, we just change it to that for the sake of the example, and then we assign that to the state, and then we update changed again to true. We call notify observers. Notify observers will basically change it back to false, and it will tell all the observers to update their state, right? So very, very straightforward. And then abstract observer class. So the abstract observer class, or rather in this case, the interface, will have the update method and the sets abstract subject, right? So in this case, we want our observer to also be able to keep track of the subject that it is monitoring, right? Okay, so in this case, and we also have the concrete observer, which implements the abstract observer. So, so this is just for testing purposes. So we have the name of the observer, and then we have our abstract subject, and then we have concrete observer. Oh yeah, so this is just the constructor, and then we have the update method. So in the update method, so here, for example, we simply get the updated state from the subject, and then so obviously if it's null, it means that the subject has not changed their state. But if the message is not null, then it would mean that the subject changed their states to message. And then So this is just the mutator method for setting the subject. So that's that. And then so let's look at the client class. So this is the main class, right? So in main, we basically create a concrete subject, and then after creating the concrete subject, then we create the observers, right? So we create the first observer, second observer, and then we just give them like example names, and then we register them to the subject, right? So subject.attach observer 1, subject.attach observer 2. So remember, this just adds the subjects, or rather the observers, to the subject array list, right? And then we set the observers to observe the subject, right? So then we set the abstract subjects, right? So we provide the subject, and then after that, we then check for an update, right? So observer1.update, and then we change the state of the subject. So obviously, if we call observer1.update before changing the state of the subject, then the output would be that the subject has not changed its state, because the message would be now, right? So in this case, again, so in this case, this is the output for observer1.update, right? So as you can see, it says test1 has not changed its state, which is true, right? Because we called the update function of an observer without actually changing the subject state, right? We need to change the subject first, and the subject will notify the observers, and the observers will then update themselves after they have been notified of a change, right? So this is why this says the subject has not changed its state, and then this will basically be the output for changing the state here, right? So if I change the state and provide a new message, then the output will be changing state to 1, 2, 3, and then the notify observers that is called inside of this function. So if we go back to this method in the subject class, so remember, notify observers here will cause all the observers to call their own update methods, right? So that is why when I call change state here, it will call notify observers, and notify observers will call the update function of each observer, right? So that is why the update methods are being called in the notify observers method of the subject class, or the concrete subject. Again. So do you have any questions regarding the observer design pattern? Yeah, so either you guys completely understand this, or you are stressed out about the semester test. So which one is it? Yeah, so in any case, so please make sure that you try and understand this properly, because it will be part of your exam, right? You will have to do a design pattern, at least one design pattern. Usually, I think last year it was 2 design patterns, but obviously year on year it changes. So you can't really bank on what happened last year, right? So, but you will have to do at least one design pattern. So we'll give you a problem, and then we'll tell you, solve this problem using a design pattern. So you have to draw the UML and write the code and all of that stuff. So if you can't understand it now, make sure that you understand it, or send an email, go to the assistant's lab, ask the assistant, make sure that you understand it. Okay, so command design pattern. So this is also known as action or transaction. So this design pattern is very straightforward. basically applicable to problems where like you have this one class or this one entity that's always issuing commands to the other entities, right? So an example of this is in a factory. For example, if you have one controller device that's sending commands to other devices, right? So the other devices just receive commands. The only thing that they need to check is what type of command it is, but the workflow is always the same, right? There's always a controller that's issuing commands to other devices, right? Or another example is if you are playing a video game and you're holding a controller, and obviously when you press commands on your controller, there's actually an object in the game that represents you, the player, and you could use the command design pattern in the sense that the player is the controller, right? The controller class, and then you have all the other entities, such as, you know, if you're playing a fighting game, the weapon class could be an entity that receives a command from you, or something like that, right? So you can apply it to many, many different things. The key is understanding the essence of the design pattern, right? So that whenever you see a problem that could be solved using the pattern, then you can easily, transfer that knowledge into solving that problem. Okay, so in this case, we encapsulate the request as an object, right? So we create an object that represents a request, right? And this allows us to parameterize clients with different requests, right? We can also queue requests. We can also log requests, and we can also support undoable operations, right? So an undoable operation in this case is an operation that can be reversed or that can be canceled or undone, right? So that's what the statement means in this case. So this is used when you want to parameterize objects by an action to perform, right? So for example, polymorphism plays a huge part in this case as well, because when you send a command, sometimes you don't really care what instance it is. Only the class that's receiving the command cares about that, right? But in many cases, you just want to encapsulate a command and think about it as a command, right? Not what type of command it is, right? So this will make sense when we continue looking at the design pattern. You also want to, for example, queue requests, right? So if you have a list of commands, you could create an array list of commands, and then you could just press play, like in a factory, for example, and then your controller would just go through the list and execute all the commands. Or rather, dispatch the commands so that they are executed by the other classes that are supposed to execute them. Okay, and commands can have a different lifetime to the original request. So we'll also look at that. We can also support undoing actions. So you can undo a command or undo an action. So in that case, you can store a state, for example, in the command so that later the command could be undone. You can also log changes, as the commands themselves can be stored and repeated if they need to be, right? So you can create a log of commands, and then you can store them and repeat them when necessary. Okay, and then you can also use it if you want to structure a system around high-level operations that are built upon primitive operations, right? So in this case, it goes back to what I was saying before, that, for example, let's say, let's think about a light bulb, right? So if you have, let's say, a smart home, and you want your controller to be able to turn off your light bulb or turn it on, the main idea is that the high-level operation is that you are sending a command to the light bulb, right? So you don't really concern yourself with what type of command it is, right? It could be powering on or powering off, right? But the main point is that you are sending a command to the light bulb. And so that's the high level property of this pattern, right? But the low level details of it is the mechanisms behind switching on, right, and switching off, right? So sometimes the client that is sending the command doesn't care how the light bulb will turn itself on or how it will turn itself off, right? It only cares about the fact that it sends a command to the light bulb and the light bulb will, do the mechanisms that it needs to do to turn on or turn off, right? So the high level operations are built upon other primitive actions that sometimes you don't even care about and you don't really care how they are implemented. So the command structure is you have a client. So this is the client. So this would be your main class, for example. And then you have an invoker, right? So you have a class that invokes a command, right? And then you have a concrete command. So before we talk about the concrete command, let's talk about the abstract command. So you have an abstract command, which basically executes a command that is being provided, right? So, and then the concrete command then provides its own way of how that command should be executed, right? So that's the concrete implementation. And then you have a receiver, which receives the command, right? So the receiver class will then perform the action, right? So executing the command is different from the low-level details of how the action is actually performed, right? So the receiver of a command will then perform the action. So in this case, we have as I mentioned, the abstract command declares an interface for executing operations. The concrete command then defines a binding between a receiver object and an action, right? So that is why, so we'll see in the code how that is exactly implemented. And then the concrete command implements the execute method by invoking the corresponding operations on the receiver, right? So the concrete command will know about a receiver, and the receiver knows how to perform the low-level actions that are associated with a certain command, right? So if the command says power on, it knows how to do that. If it says power off, it knows how to do that. So any class can be a receiver class. So the invoker asks the command to carry out the request, and the client creates a concrete command and sets the receiver, and the client obviously specifies which commands are carried out, right? So here's our example of a light again. So let's say you're turning off or on a light remotely. So using the command design pattern, the light can be viewed as a receiver, right? So that's the receiver of the command. And the on and off actions are a type of command, right? So we're going to create a command class called power on command, create a command class that's called power off command, right? And then you have an invoker, right? So you can think of the invoker as the remote control, right? So this is the controller, right? So when you, the client, let's say you are at a stadium watching football and it's getting late, you send an instruction onto your phone so that a light is turned off in your house. Then what you are sending the instruction to, that is the invoker, right? That is the remote control. So it invokes the particular command. So the client is the program that directs when the remote is used to initiate the on or off action, right? So there's a client, which is usually you. There's the invoker, which is the mediator, right? That sends the commands, which is also the remote control. And then there's the receiver that can receive commands. And then the receiver is also the one who knows how to perform the actions of the command, right? Okay, so abstract command interface. So as we saw in the class diagram, the abstract command interface is the execute method. and then the concrete command class. So let's look at that. So this is the turn on command, right? So it implements abstract command, and it has a reference to the receiver, right? So concrete command turn on, and then it would receive so it receives, or rather it takes a receiver as a parameter, and then when we call the execute function, then it will tell the receiver via the reference to turn on, right? And then we have the concrete command class. So this is the turn off class, and then it also maintains a reference to a receiver, and then you can set it using the constructor, and then it will tell the receiver to perform the action, right? And then this is the receiver class. This is the simplest of the classes. So this has all the functions that exist for all the possible kinds of commands, right? So it has a turn on function for turn on commands. It has a turn off function for turn off commands, right? So this is just a flag to check if the light is currently on or off. And then, so if you're turning the lights on, then on is true, off, then on is false. And then this is just getting the states, right? So you just want to check, is the light currently on or off? Okay, so another important thing here that I just want you guys to keep track of, right? So if you look at the, oh yeah, we actually haven't gotten to that class. Oh yeah, I actually wanted to talk about this class. The most important thing to look at in the command design pattern is the invoker class, right? So the invoker, as you can see, does not know about the concrete commands, right? It doesn't have to know about a turn on command or a turn off command, right? So even if you added another command class in the future and called it sleep command or something like that, the invoker does not have to know about that, right? So it only knows about an abstract command, right? And all it does is that it also has its own reference to an abstract command. And what it does is it simply tells the command to execute, right? And when that command executes, based on what type of command it is, then for example, if it's a turn off command, then that command will actually call the appropriate function from the receiver, right? So that's very, very important to note from this design pattern. Okay, so here's the client. So in this case, so we have the invoker, and then we have the receiver, and then we have our two commands. And then, so remember, we have to provide a reference to the receiver, to each command. So this is the receiver of this command. This is the receiver of that command. And then, so we set the command. So in this case, we provided the turn lights on command. And then we just call the press button method. And then we just get the states, right? So we just want to check if the states really changed. And then we can set the other command as well, and then press the button and then check the current state, right? So obviously the first one would be true in terms of the output, and then the second one would output the value false. Okay, so unfortunately we couldn't get to the next set of design patterns, but I did upload the slides to Eve. So when I see you tomorrow, then we will talk about those design patterns, right? So this is a 4-part lecture. So this is part 1, so that's part 2, there's part 3, and then there's part 4. Okay, but thank you very much, and all the best to those who are writing on Saturday, and enjoy the rest of your day.